Hello and welcome. Today we are going to get into a topic you see absolutely everywhere: percentages. Seriously, once you master them, you'll see them in a whole new light, whether you're looking at a sale at your favorite store or just watching the news. It's a real superpower for understanding the world. So let's jump right in.
All right, here's the game plan for today. First, we're going to start with the absolute basics. What even is a percent? Then we'll build up our toolkit with some core calculations you'll use all the time. After that, we'll put those skills to the test with some real-world problems. And to wrap it all up, we're going to master the tricky concepts of percentage increase and decrease.
Okay, first things first, we have to start at the beginning. Let's get to the bottom of what the word percent and that little symbol you see everywhere actually means.
You know, it's actually way simpler than it sounds. Percent literally just means for every 100. That's it. So whenever you see that percent symbol, just think of it as a special kind of fraction, one that's always out of 100. So if someone says 8%, they're really just saying 8 out of 100.
And because of that, switching between percentages and fractions is a piece of cake. It's a two-way street. If you want to turn a percentage into a fraction, you just put it over 100. So as you see here, 45% is just 45 over 100. And to go the other way, from a fraction to a percent, you just do the opposite. You multiply by 100. So 3/5 times 100 gets you 60%. Simple. Okay, so now that we've got the foundation solid, let's start building our mathematical toolkit. These are the core calculations you're going to need to solve pretty much any percentage problem that comes your way. This right here is probably the question you'll face most often in your day-to-day life. I mean, think about it. What percent of your to-do list did you finish? What was your score on that last test? It always comes down to this: finding X as a percent of Y. So let's check out this example. The question is, 36 is what percent of 144? The method is super direct. You just make a fraction. You put the part, which is 36, over the whole, which is 144. Then you multiply by 100 to make it a percentage. And boom, there's your answer, 25%.
But what if the tables are turned? What if you already know the percentage and you know what that percentage is worth, but you need to figure out what the original total was?
Now this is interesting because all we have to do is kind of work backwards. If we know that 32% of some mystery number equals 80, we can find that number by taking 80 and multiplying it by, you guessed it, a flipped version of our fraction, 100 over 32. And that gives us the original number we were looking for, 250. All right, enough with the theory. Let's see how all this stuff actually works in the real world. It's time to take our new tools and solve some practical, everyday problems. Okay, here is a classic problem you might see. It's all about budgeting. So a man spends 65% of his salary each month, and he manages to save 525 rupees. The big question is, what's his total monthly salary? Now, the trick here is to first figure out what percentage he saves, right? If he spends 65%, then he must be saving the rest, which is 100 minus 65, or 35%. So now we know that 35% of his salary is equal to 525 rupees. And just like we did before, we can use that to calculate the whole thing. His total salary is 1,500 rupees. Okay, let's kick it up a notch. This one's a little more complex. We've got an election. The winner gets 57% of the vote. We also know that the winner won by 4,900 votes. So, how many people voted in total? So, before we reveal the answer, just pause for a second and think about this. The key piece of the puzzle is that 4,900 vote margin. How would you express that number as a percentage? And here's how you crack it. If the winner got 57%, well, the loser must have gotten the rest, which is 43%. So the difference between them in percentage points is 14%. That means the 4,900 votes represent 14% of the total. And once you know that, you can work backwards to find the total number of votes polled, which is 35,000. See how that works? You know, for problems where you have overlapping groups, a Venn diagram is an amazing tool. It just makes everything so much clearer. Take this example, which shows exam results for students who could have failed English, math, or maybe even both. Let's break down what we're seeing here. The part in the middle, the overlap, shows that 27% of students failed both subjects. Then you can see 3% failed only English and 8% failed only math. If you add up all those fail groups, you get a total of 38%. So if 38% of students failed something, that means the rest, the other 62%,
must have passed both subjects. All right, we're on to our final section. And honestly, this might be one of the most useful applications of percentages in the real world, calculating things like price changes, growth rates, and depreciation.
Okay, here are the two big formulas you need to know. For a percentage increase, you take how much it increased by, divide that by the original amount, and then multiply by 100. It's the exact same logic for a decrease. The really crucial thing to remember is that you always compare the change to the original starting point. But here's where things can get a little tricky. What happens when you have more than one percentage change, one after another? Like a price goes down, and then that new sale price goes up. This is a super common trap that lots of people fall into.
Let's walk through this carefully. We start with 5,000. First, it's decreased by 10%, which takes us down to 4,500. Now, and this is the most important part, the 20% increase gets applied to the new number, 4,500, not the original 5,000. So 20% of 4,500 is 900. We add that on, and our final number is 5,400.
So the huge takeaway here is that a 10% decrease followed by a 20% increase is not a 10% increase overall. It just doesn't work like that. The total change from our starting point of 5,000 to our end point of 5,400 is actually an 8% increase. You have to do it step by step.
And that brings us to one last thought to leave you with. Imagine you're shopping. You find a shirt that's already on sale for 20% off, and you have a coupon for an additional 30% off the sale price. So is that a total discount of 50%? Based on everything we just covered, I'll let you think about that one. Thanks for tuning in.